Hello, welcome to the video. In this lesson, we're going to be looking at section 10.5, where we're looking at permutations and combinations. So the difference between a permutation and a combination is when you're dealing with permutation, order is important. So if you were to try to list like possible outcomes for like a race, so if you had like first, second, third, you're trying to figure out the people, depending on how many people that are racing, how many possible outcomes could there be. So someone has to be first, someone has to be second, someone has to be third. So order is important in that particular instance. Combinations are are trying to find arrangements where order is not important. Where like if you are trying to pick, uh, like electives for a class, or if you're trying to look at the appetizers at a restaurant, if you only have, if you can choose two appetizers or something like that, and there's so many appetizers, how many combinations of appetizer choices could you get? There's no order in, how you get them. It's just how you get them. So a lot of things you have to be able to figure out is, one, are we dealing with a permutation problem or are we dealing with a combination problem? So if we're looking at permutations where order is important, the first thing that we have to look at is something that's called factorial. So if we have any value that has that exclamation point at the end, that just means that whatever that number is factorial. So the example they have right here is we have 4 factorial. All right, they do it in reverse or 4, 3, 2, 1. I like to start with 1. So like for instance, if I wrote in like 3 factorial, I like to do it as 1 times 2 times 3, which equals 6. So 3 factorial equals 6. Now, if you have a situation where you have a permutation and you have n number of objects that are taken at r at a time, then you look at this formula right here for your permutation value. Okay, it is going to be n factorial divided by whatever n minus r factorial. So like the example they have right here, where you have 4 objects taken 2 at a time, where you have, so n in that case is 4 and 2 is r, so that's where they get those values there to get a value of 12. All right. One of the things you have to keep in mind is n is always going to be a larger number than r. N will always be a larger number than r. So for this particular question, it says, in how many ways can you arrange the letters in the word house? So the first thing you have to figure out is how many letters are there. There's 1, 2, 3, 4, 5. There's 5 letters in the word house. Since they didn't say how many arrangements, a specific number of arrangements, so I'm just assuming that we're looking at a permutation where we have 5 objects and we're arranging them 5 different ways. So since they're the same number for n and r in this case, it is just going to be 5 factorial. So 5 factorial is 1 times 2 times 3 times 4 times 5. When you multiply all of those together, you get 120. So there's 120 possible ways you can arrange those letters in the word house. For number 2, they want you to figure out how many ways you can arrange 3 of the letters in the word March. So we got 1, 2, 3, 4, 5. This is also 5. So this one's going to be a permutation where you have we have 5 objects, but we're arranging them 3 at a time. So this is now going to be 5 factorial on the top using the formula divided by n minus r, which is 5 minus 3, which is 2 factorial. So this is going to be on the top, 1 times 2 times 3 times 4 times 5, divided by 1 times 2. Those get canceled, so all I have to multiply is 3 times 4 times 5. I get 60. All right, so here it says 10 horses are running a race. How many different ways can the horses finish first, second, and third, assuming there is no ties? So, like I said, since it's a race, I kind of talked about that at the beginning. Because it's a race, order is important. So we're looking at a permutation. There are 10 horses in this race, and we want to know how they finish first. So we're going to arrange them kind of 3 different ways. So on the top, it's going to be 10 factorial divided by 10 minus 3, which is 7 factorial. So this one's kind of nice because we got 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. And on the bottom, we're like 1 times 2 times 3 times 4 times 5 times 6 times 7. Well, all of these terms on the top and the bottom get canceled, so all I'm really multiplying is 8 times 9 times 10. So my answer of 8 times 9 times 10 is 720. All right, so here is a probability question. It says, for a town parade, you will ride on a float with your soccer team. There are 12 floats in the parade, and their order is chosen at random. Find the probability that your float is first and the float with the school's chorus is second. Okay, so the first thing you have to do, so we got step 1, is first we have to figure out how many possible outcomes are there for the order of this parade. So since there's no specific number for arrangements, it's going to be a permutation where I have 12 objects and I'm arranging them 12 different ways. So this just means it's going to be 12 factorial. So 12 factorial is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12. Multiply all those together, I get 479,001,600. So there's that many different possible outcomes for 12 floats. The second step is we need to figure out the favorable outcomes. So there are a bunch of favorable outcomes because what we need to do is we need to figure out when your float, the soccer team is first and the school chorus is going to be second. So what that means is that leaves us with 10 other floats which we don't know where their arrangements are, but we certainly don't care where they are. But all we care about is us being first and the chorus group being second. So what we're going to be looking at is a permutation where we have now 10 objects and we're arranging them 10 different ways. The reason why we took out the 2 is because we want the soccer team to be first and we want the chorus to be second. So we're just automatically saying, all right, those scenarios, soccer's first, chorus is second. Let's see what happens with the other 10 floats. So of those combinations, it's gonna be 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. When you multiply all those together, we get 3,628,800 favorable outcomes. So then the last step, the third step, is you just take the favorable outcomes, 3,628,800, and divide it by the total possible outcomes, which is 479,001,600. And when you reduce it, it turns into 1 over 132, which is about 0.76%. So you have less than 1% chance of this happening. All right, so very small percentage, but um, a percentage nonetheless. So when you're looking at combinations, again, there is a combination formula. Same idea. N is still going to be greater than R, but now the formula for that is n factorial still on the top, but on the bottom you have n minus r factorial, but then it gets multiplied by r factorial. So it's going to be taking away some values with respect to the permutations because there is not going to be as many outcomes because order is not important. So here it says list the possible combinations of two letters chosen, lists A, B, and C. All right, so since it's two, so it's a combination where I have 1, 2, 3, 4, and I have arrange them in two different ways. So with this one, it's going to be 4 factorial on the top divided by 4 minus 2, which is 2 factorial, and then r is 2, so it's 2 factorial. So I have two separate 2 factorials in the denominator. So on the top, it's 1 times 2 times 3 times 4, and then I got 1 times 2, and then 1 times 2. So those get canceled, so now I'm left with on the top 12, on the bottom I'm left 2, so my result is 6. So there's 6 possible combinations of 4 objects, arranging them in two at a time. So again, this is just the same idea. This is 1, 1, 2, 3, 4, 5. So this is just a combination where I have 5 and 3. Okay. If you want me to go through it, more than happy to. Please leave a comment if you would like me to. All right, so here it says you are ordering a sandwich at a restaurant. You can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? So again, this is a combination where you have 8 possible side dishes, but you can choose 2. So it's going to be 8 factorial on the top divided by 8 minus 2, which is 6 factorial, and then r is 2 factorial. So what I like to do, especially with combinations, because I know there's going to be some kind of bunch of cancellations, I look at the largest 1 factorial on the bottom, and I know that between the top and the bottom, 1 times 2 times 3 times 4 times 5 times 6, that's all going to be canceled. So I'm just going to write it on the top, omitting all those. So I'm going to have 7 times 8 on the top. And on the bottom, since this is going to be canceled, all I'm left with is 1 times 2 on the bottom. So 7 times, it just allows you to write less if need be. So 7 times 8 is 56. 1 times 2 is 2. And that gets me a result of 28. So that means there's 28 possible outcomes with a combination of 2 side dishes with a list of 8. All right, so now here, this is the probability one with respect with combinations. So it says a yearbook editor has 14 photos, including one of you and one of your friend. To use in a picture collage for the yearbook, it says the photos are placed at random. There is room for 2 photos at the top of the page, what is the probability that your photo and your friend's photo are the two placed at the top of the page? All right, so the first thing you have to look at, just like you did with the other probability for step one, is we have to list the possible outcomes. So in this one, we it's a combination because order's not important. It doesn't say like which one's first or which one's second. Just is your picture going to be in there? So there's 14 photos and there's two that can be chosen. So it's going to be 14 factorial divided by 14 minus 2, which is 12 factorial, and then 2 factorial. So I know that because 12 is my larger one, 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12 all get canceled. So on the top, I'm just left with 13 times 14, and on the bottom, I'm left with 1 times 2. When I do all the math, I get 91 possible outcomes. The second step is I want to figure out my favorable outcomes. And the thing about it, the only favorable outcome that works is that if you or your friend gets chosen. So there's only one favorable outcome. So the probability of this happening is 1 out of 91. Last concept that we're going to look at in this section is being able to use the binomial theorem. Okay, so it says for any positive integer n, the binomial expansion of a plus b, raised to some power n can be used with respect to different combinations. All right, so here it says you can use the coefficients or use the values of these as your coefficients, which comes from Pascal's triangle. So if you recall from Pascal's triangle, so if like you start out with 1 on the top and then you move in, and 1s are always on the outside, and then you just add up 1 plus 1 here, which is 2, you come 1, and then you add another, which this is 1 on the outside. 1 times 1 plus 2 is 3. 1 plus 2 is 3, so on and so forth. This top row is like a raised to the 0 power. This is raised to the 1 power. This is raised to the second. This is raised to the third. Now, you can use Pascal's triangle if you like, or you can use the combination values as well. My recommendation is if your exponent is not an overly large value, you can use the Pascal's triangle. But if it's something that's relatively large, like I would say like anything like 4 or 5 or larger, I would use this formula here. Okay. So for instance, we have, it says use the binomial theorem to write the expansion of x squared plus y raised to the third power. All right, you can use the binomial theorem, but since it's something that is, less than 5 as an exponent, I was just going to use Pascal's triangle. So if you look at Pascal's triangle raised to the third power, my values on the outside are 1, 3, 3, 1. So here's how would be set up. So for the first one, it's going to be 1, and then I got my value of A is right here, my value of B is right here. So A, so x squared for instance, is going to be raised to the third power. My by is going to be raised to the 0. Plus my value then was 3, came from Pascal's triangle. Now I got x squared, and I subtract this one here. So this is now going to be 2, and now it's going to be y to the first plus 3 times by x squared. Now I take this one more time. That's 1. Now this is going to be y squared plus 1 x squared to now the 0 power y to the third. All right, once I take care of all of these, I get this right here is just 2 times 3, which is 6. So this is x to the 6th power plus 3x to the 4th y to the 1st plus 3x squared y squared plus this is the 0 power, so that's just going to be 1. So I'm just left with y cubed here. So my expanded um, cube of this binomial is x to the 6th plus 4. No, I'm sorry. X to the 6th plus 3x to the 4th y plus 3x squared y squared plus y cubed. All right. Here, they want us to find the coefficient of x to the 4th in the expansion of 3x plus 2 raised to the 10th power. All right, so here is something I would then use that by the binomial theorem, okay? Because well, for one, they just want us to find one thing. They want us to find this coefficient that is attached to x to the 4th, okay? So what you're going to do is, if you look at this, since everything here is n, everything here is n, everything starts with n, well, n in this problem is 10. So n equals 10. So to find out where x to the 4th is located, what you're going to do is this. So say if I had x to the 10th, that's going to be a combination where I have it's 10 and 0. So if I got x to the 9th, it's going to be a combination where it's 10 and 1. So if I go all the way down to the x to the 4th, that's going to be a combination where n is 10 and my value for r is 6. So now I'm just going to use that combination formula, which is going to be 10 factorial divided by 4 factorial, which is the difference of 10 and 6, times it by 6 factorial. Okay, so I realize that 6 is my larger value here. So that means 1 times 2 times 3 times 4 times 5 times 6 all get canceled. So on the top is just 7 times 8 times 9 times 10. And on the bottom is 1 times 2 times 3 times 4. When I do all the math, it is going to result as 210. So now I know that this value here is 210. So I'm going to get 210, and then my value for A is 3x. So now I got 3x. That is going to be raised to the 4th power because of my x to the 4th. And then my B, which is 2, that is going to be raised to the 6th power. So these values must add up to 10. So to figure out what the coefficient is, so now I got this 210 times it by 3x times it by 2 to the 6th power, which is 64. So to find the coefficient, I'm going to take 210 times it by 3 times it by 64, which gets me, oh, hold on. I'm sorry. I have to raise this to the 4th power. My bad. So this means that 3 to the 4th power is 81. So now it's 81x to the 4th. All right, my apologies. So now I have to take 210 times it by 81 times it by 64, which gets me a coefficient of 1,088,640. So the coefficient of x to the 4th is 1,088,640. and that is being able to look at permutations and combinations. Hope this helps. Till next time.